Okay, welcome back. Let's take a look at the remaining topics in this lesson. We're going to take a look at those boot options of how we can boot an autodeploy host either in a stateless caching mode or in a stateful install mode. But beforehand, we have a couple of interesting options that you can add to an auto-deployed environment. For instance, this is what we call running custom scripts on stateless hosts. What is this? Well, if you think about it, you have all these different rules, right? You have one rule that sets the image that's going to be set down to the host. Then there's another rule that you can define the host profile that's going to be sent to the host. And then another rule that says where the ESX server is going to sit in your inventory, which cluster, for instance. But what if there's something else that needs to be configured on that host that somehow none of those options can actually work for? This is usually for something that just doesn't work as a host profile. So sometimes you may need to add an additional set of a couple commands or scripts or a script that can be executed after the host has been brought online, had the host profile applied, and then it's now connected. And now finally, why not let auto deploy just log into that host, basically push down one more set of scripts that can then be run on that host. Now those scripts, they can be run either in the ESX server's native scripting language. So in the BusyBox shell, that's actually the A shell, ASH. So you can write it in there. It's basically a clone of Bash. You can also write your script in Python if you like. And so you create these script bundles. It's basically a zipped file of all the different scripts you'd want to execute on that host. And then you have to give them actually a name in alphanumeric order. So if you have a couple different files in there that represent the variety of scripts, just make sure the files that are in the zip file are in alphanumeric order. And that's the order that they'll be executed if they get then pushed down to the host. They can't exceed as a group more than 10 megabytes. And you essentially tell the auto deploy configuration, you have one more rule you'd like to set up. Basically a script bundle rule, right? Does the host or which hosts need to have these script bundles? Now, you see here in our slide, you can actually run a PowerShell script to configure that rule. You can also use the vSphere client. That's also as an option. So you'll have yet another tab to work through in the vSphere client when it comes to auto deploy. Another interesting additional option is what if you have a large environment and you would like to try to cache or at least try to provide a proxy host that can cache the auto deploy imaging capabilities. So instead of having one central vCenter server that's under stress for having to, deploy multiple ESX servers simultaneously, you could actually try to balance the load of your vCenter server or auto deploy host by adding a couple additional proxy servers, if you like, or maybe even place those proxy servers in data centers of where you have other ESXi hosts, right? They're all being served by the same vCenter server, but you might have other ESX servers that are in other data centers. You could have a proxy host that's set up at that other data center. And what that proxy host is going to provide is actually the PXE boot process, as well as being the main boot download server that will download the images the image down to the host. The host will still get its host profile from the central vCenter, but the big heavy lifting things, right? Being able to push down the actual 300 megabyte ESXi image in a sense, right? So you can set these hosts up in remote data centers or maybe just to balance the load of that one central vCenter server. What you do is there's actually a PowerCLI command called add proxy server. There's also an option within the vSphere client where you define who the proxy server is. That's going to register that server with the vCenter system. And then you will have to take the TFTP zip file that you download and usually place on the autodeploy server, download another copy down to these hosts, and edit the boot file so that the boot file is actually pointing to that host, because normally the boot file points to vCenter. Open up the proxy boot file and just make sure it's got the IP address of your proxy host. And then also just make sure that the DHCP server, right? The DHCP server will need to make sure in its DHCP reservations that the IP addresses that are going to be for the set of servers that are going to get their PXE files from the one proxy host, just make sure that's set up in the DHCP server, that in the DHCP rules that these hosts are going to have their IP addresses sent by the DHCP server, but then their TFTP server must be one of these proxy hosts. So you just make sure the DFTP is pointing to the proxy host. In the proxy host, the actual boot file that's sent down through PXE is also pointing to the proxy host. And then you've already run this add proxy server command or have done the equivalent in the vSphere client to register the proxy server with the autodeploy server. And then it will actually synchronize and be a cache for your autodeploy host. So that's nice, being able to distribute the load around. Now, our other options, of course, with the auto deploy are, besides just straight stateless mode, there is stateless caching, and then there, of course, is stateful install. With stateless caching, how you enable this is you actually go into the host profile for the ES6 servers that are going to be stateless caching hosts, right? These are hosts that have an internal hard drive that it doesn't typically boot from. That internal hard drive is used just as a backup in case the primary connection just isn't available, right? So for instance, the boot order of your ES6 server still remains the same. They'll boot off the network first, and then they'll try to boot off of the hard drive. And if there is no network connection, vCenter or Update Manager or the auto deploy server isn't running or isn't available, it will then at least try to boot off of its backup image. So of course, this is all provided the host is at least booted once prior to this, so it has a cache backup of the boot image. So basically in the ES6 server's host profile, you simply define that under the system image cache configuration section, just set it so that it is actually going to be stateless caching, where it typically will cache off of the local hard drive. Or if you have a local USB disk, you'd rather use that as a cache instead. You see there's another option in here that lets you choose both either a traditional stateless cache or a stateless USB drive. Then essentially the host still boots off of the network first, boots off of auto deploy as its standard practice. But if something goes wrong with auto deploy, if there's something wrong with the network, it will try to boot off of its backup cache copy that's on disk. So it never does that as a first choice. It's always done as a second choice. And then our other option is actually a completely different process altogether. This is the stateful install. This is where the ES6 server just boots its first time with auto deploy, and auto deploy installs a stateful install so that the host will never connect back to auto deploy again. It's basically got its image and he's ready and he's done. So now that boot order is a bit different. This boot order is boot off of the disk first and then boot off of the network second choice, right? So if there is no image, so it's never booted before, it's got to go and hit a second choice, boot off the network and get the image. And then now that it's got the image, it basically boots off the disk going forward. Now we don't need to set these boot options. This is all done by assigning the ES6 server the host profile, such as the one here, right? You set it either to be stateful install, or you set stateful install with USB disk, right? Again, you have your two choices there. So now this host basically boots off the auto deploy just once, and then after that, always boots off of its disk. It's a full stateful install. It hits auto deploy just once. So speaking of stateful installs, there's actually an interesting new feature in vSphere 7. There's this new service called Lifecycle Manager. It's basically a replacement for Update Manager that we've had for years in vSphere. And, Update Manager basically patches hosts with the VIB packages, essentially. With this new Lifecycle Manager, we still get that capability, but another interesting feature of Lifecycle Manager is it has the ability to set for a cluster a desired state configuration technology built into it. It basically creates an image that all the hosts in the same cluster should be compliant with. So instead of having to worry about individual VIBs and patches and so on, you basically declare an image state for your cluster, which is basically a custom image built just like you would have built an image for auto deploy's use. Instead here, we make that image for the use of Lifecycle Manager. So we can actually nowadays use this tool, use Lifecycle Manager, to stand up a new host. You join a host to a cluster, you have a image designation in the cluster for which image you need to have the cluster compliant with. That host joins the cluster, and then you use Lifecycle Manager, which basically is going to draw auto deploy technology to then install the image on that host with a host profile, of course. And so it's a lot like an auto deployed mechanism, but you're doing this yourself as the administrator, not really just having a host pixie boot. This is actually a host getting the image pushed down to it from a central point. So you still build the custom images with the image builder utility, but this can actually leverage auto deploy to push the image to a host. That's actually a pretty interesting new capability introduced in vSphere 7. So that was the look at the various functions of auto deploy. We took a look at the purpose of auto deploy, and you should at this point be able to describe how an auto deployed host boots. So that's our lesson here. We'll take another quick break, and then we're going to come back and actually go through the procedure of configuring an auto deployed environment. So stay tuned. We'll see you in the next lesson.